Okay, so 10.3 is using chords. And we do have 4 theorems. Some of them work together, so you can kind of infer like different things. So theorem 10.6. And I'm gonna, like, if you want to look up the words and write them down, fantastic. I'm just gonna draw the pictures and work on them from there. So remember, a chord is inside of a circle, and it's like a segment, starts and stops on the end, on the edge of the circle at some point. So what this theorem says, that if the chords are congruent, then the arcs are congruent. It also says if the arcs are congruent, the chords are congruent. Okay, so if you start with like AD, AD is congruent to BC, then arc AD is congruent to arc BC. If you had arc AD is congruent to arc BC, then the chord AD is congruent to the chord BC. So back and forth. So it's, in my opinion, it's more important that you're able to look at a picture and say, oh, this chord is congruent, so that arc is congruent, or these chords, so those arcs rather, than it is to like memorize the words that go along with it. So you're gonna see like me kind of using pictures quite a bit more. Okay, so if we have a diameter and a chord is perpendicular, okay, so you know it's a diameter when you see that point in the middle. Okay, so basically what this is saying is if AC is perpendicular to DB, and the DB part has to be a diameter. If it's not, you don't know nothing. But if it's a diameter, then what we know is AE is congruent to EC, so these segments in there, and arc AB is congruent to arc BC. So those two. Okay, this one you don't get to necessarily go backwards. Okay, so since we know two things, we don't necessarily just go, oh, well, there's one that's kind of going backwards that I'll talk about next. But on these, remember I said, I don't know if you remember, but I said chapter 10 is a lot of like, okay, here's the circle, and then, all right, now there's this algebra thing to do. So you're trying to essentially come up with like equations to solve. Now, some of them might just be really simple like things to solve. It doesn't mean it has to be this huge, crazy algebra problem, but you're going, oh, okay, like this chord AD and BC are congruent. Okay, now I know that the arcs are congruent, so I can solve. Or, oh, this is diameter and it's perpendicular, so that equals that. And then you can solve something. So I'm going to do an example or two in just a second. But I did know already that this like AE part and this EC part were congruent. That was like, conclude that the arcs are congruent. So 7 and 8 definitely work together, but it's not, you can't use the arc. I guess that's like and if the chords are congruent, then the arcs are congruent. Okay, so 10.6 and 10.9 work together. This theorem, 10.6, says if the arcs are congruent, then the chords are congruent. That's this theorem, 10.7. Diameter, perpendicular. So I know that like each part of that chord is the same, and I know the arcs are the same. Okay, theorem 10.8. It kind of is going backwards from the one that we just did. So it's saying like if you start with that, so you have to have one chord bisect another and be perpendicular. So if we have a chord, the two chords that are perpendicular and one is bisected, what do I get? What do I know? The chord is a diameter. So it's similar to like the other one, so I get to put my dot there. And then it kind of reverts back to theorem 10.7. Oh, now that it's a diameter given to me in the problem, you know, from A to this, I didn't put the C or whatever in the middle. But then because I know it's a diameter, you're able to also, the key, if you know AB is congruent to BD, I can draw it in such a way that that's true and it's not a diameter, and so forth. So it has to be the little chord segments and it being perpendicular. Okay, so let's look at a couple things to figure out. Why does it really have to do with chords? I was looking at a couple of examples in the book. Well, here's one for this last. So find like two things. So if we find EC and let's go with arc ABC. So the simple one should be EC because I have a diameter even though it's kind of crooked, and it's perpendicular. So if this AE part is 5, then the EC part is also 5. Okay. And then the ABC part, well, it's perpendicular and it's a diameter. So the chords are equal and the arcs are equal. So I would want to do a little equation there. And so pay attention to the questions on some of these. I'm not asking you to solve for X, I'm asking you what's ABC. So you need to like plug in the 8. And so here's where kind of knowing everything can be helpful. Like if these two arcs are congruent, well, if I plug in 8 up here, 9 times 8 is 72. Well, that other arc is already 72. I don't need to plug it into that one. So it's just 72 and another 72, or 144 degrees. So just make sure that you're answering the question on all of these when you solve for x. Okay. All right. Last theorem. This one is what they're going to ask you to do. It's a little bit more tricky. And this, I should have wrote the number. Theorem 10.9. This theorem will help you or we'll go kind of with the theorem 10.6. I need to draw that one better. Okay, so this one I am going to write the words down. So it says in the same circle or congruent circles, chords are congruent if and only if. So remember, if and only if means you get to go back and forth. They are equidistant from the center. So what it's saying is, if these little segments in the middle are congruent, then the whole chord is congruent. If the whole chord is congruent, then they're the same distance from the center. So if you start with this picture, okay, those little pieces, and they're the right angles there because that's distance is always perpendicular. It's always like in a straight, like the shortest part, which is always going to be a 90-degree angle. So if you know these two are congruent, then you know those big chords are congruent. And if the chords are congruent, then they are equidistant from the center. You get to go in both directions. You can tie those two theorems together. Okay? All right. Now, this theorem, the problems that you're going to see in the book are a little bit tricky. They're definitely layered. So let me draw this picture. All right, so U, C, center was C, T, X, Y, V, and S. This problem's in the book, in case you're wondering. So it tells you that QR equals ST, which is 16. So it gives you a distance. CU is 2x, and CV is 5x minus 9. And the direction, and the problem says find the radius. Okay, so the radius from the center of the circle to the edge of the circle. But all right, they tell us this stuff for a reason. Okay, like, so they didn't tell us this to not use it at all. So if I know that Q, so this is where being able to look at a picture and kind of make some conclusions is really important. All right, so QR and ST are both 16. Well, I noticed that, like, CW all the way down to X, that's a diameter because it goes through the center. And QR is perpendicular. So I don't think I'm going to be really using the arc information, plus I don't know any degrees, but I do know that from Q to R is 16, and if they're going to be like this Q to this U and U to R are going to be the same, that's what that theorem said, then this would have to be 8, that would have to be 8, that would have to be 8. I'm not going to label that one because that Y part's in the middle, but from V to T would be 8. Okay, so maybe that'll help me at some point. Okay, so I use that information, so I'm probably good with that. All right, so CU, so that's talking about this part is 2x, and this part, I'm not going to put the 5x minus 9 because it'll get confusing, but those are from the center to the edge, they're a right angle, like it's this theorem 10.9. So it's saying, well, we kind of, we get to go like back and forth kind of thing. It told me these chords, Q, R, and ST, are congruent. It told me they're 16. Therefore, it's the same distance from the center to that chord. So 2x and 5x minus 9 are equal. And I can solve for x. So x equals 3. I'm going to go back and erase. So if x is 3, then that means that this is 6, and this is 6. So, radius from the center to the edge, and so here's where we kind of get some creativity. Because you might say, well, if from C to U is 6, well then if I can figure out from W to U, then I can just add them together. And you're right, you could do that, except for we don't know any theorems about from W to U. No way to do it. Okay, or you could, on the other side, it's really even like kind of worse. So this is where we need to remember the radius is from the center to the edge. So if I were to draw that's a radius, that green thing, that dotted line. Let me make it solid. I don't know why I did dotted, but that's a radius from the center to the edge. And so if you notice, I just created a right triangle. So I can do 6 squared plus a squared, 8 squared equals the radius. Remember, this is r squared. Square root of both sides. And finally, the radius is 10. if you remember 6, 8, 3, 4, 5 triangle, which we talked about with right triangles, and then you can do times 2, that's a 6, 8, 10. If you recognize 6, 8, the radius is 10, and you didn't show this bottom part, I'd buy it. I think that's like smart. But you got to kind of do like the blue part also. Okay. All right. So you're going to have 2 problems like that, where it's going to say find the radius, and you're going to know that it's equal distance from the center to the chord, and then you're going to have to create a right triangle to solve. Okay, the rest of them will be much more straightforward, where you're not going to have anything like crazy. This is a little bit more like out there. So the rest of them should just be this equals this, and you solve a little, equation. So it looks like, solve for x is like on like 4 of them. Find the measure of the arc. So remember, the arc is going to tell you that the chords are congruent. So looking for congruent chords, then you can figure out the degree of the arc or the chord. So there's some that are red for the chord. But if you know the arc, then you know the distance of the chord, or you know that the chord's congruent. Okay. All right. Some more kind of information on circles. 4 theorems, so we're up to 9. Here's theorem 10-9. So a lot of information. I'd be going back and reviewing these a little bit each day. All right. Have a good rest of your day, guys. We'll see you tomorrow.